You're welcome back to my channel. Today we shall be studying gas laws. The gas laws are the laws that use kinetic theory of gases to explain the observable facts concerning the behavior of gases. And the gas laws include Boyle's law, Charles' law, Gay-Lussac's law, which is also known as pressure law, general gas law, ideal gas law, Dalton's law of partial pressure, Gay-Lussac's law of combining volume, Avogadro's law, Graham's law of diffusion. These are the 9 laws we are going to be looking into. And from the picture being depicted under each category, it actually illustrates what the law entails. Quantities used in the measurement of gases. Now, looking at these quantities, it will be needed for calculations when we go to the examples of each law. Now, the following parameters or quantities are usually given in problems about gases. Number 1, volume. Volume is measured in milliliter or centimeter cube or decimeter cube or liter. Then the relationship between them is that 1000 centimeter cube is equal to 1000 milliliter equals to 1 dm cube and also equal to 1 liter. That you should take note for conversion sake. Number 2, pressure, represented by P. It is measured in atm, that's atmosphere, or millimeter mercury, or torrs, or Newton per meter square, or Pascal. These are the units of pressure. So the relationship between them is also as follows. 1 atm is equal to 760 millimeter mercury, which is also equal to 760 torrs. 1 atm is equal to 101325 Newton per meter square, which is also equal to 101325 Pascal, or 1 Pascal equals to 1 Newton per meter square. Number 3 is temperature. This is the third quantity needed, which is represented by T. It is measured in degrees Celsius or Kelvin. And when you are given in a problem, you need to convert degrees Celsius to Kelvin. And the relationship of conversion is that K is equal to 273 plus degrees Celsius. So make sure you add 273 to every degree Celsius value you were given in order to convert to Kelvin before using them or substituting them in your calculations. Number 4 is mass. Mass is measured in gram. Number 5 is number of mole and measured in mole. And number 6 is gas constant, capital letter R, measured in dm cube multiplied by atm slash mole multiplied by Kelvin. And R is equal to 0.0821 decimeter cube or multiplied by atm per mole Kelvin. Or R is equal to 8.314 joule per mole Kelvin. Now let's take them one by one. Boyle's law. Boyle's law states that the pressure of a given amount of gas is inversely proportional to its volume, provided the temperature remains constant. Mathematically, Boyle's law is expressed as below. As we can see there, P is inversely proportional to 1 over V. And therefore, removing the inverse proportionality, we are going to introduce a constant K. So P is equals to K over V. Then by cross multiplying, we get PV equals to K. And therefore, because the gas moves from initial amount to final amount, or change state, then we are going to get P1 V1 equals to P2 V2. So this will be the formula to be used. In this respect, P1 and P2 are initial and final pressure, while V1 and V2 are initial, final, and final volumes. With the formula gotten, it means that if the volume of a gas decreases, its pressure increases, and vice versa, as long as the temperature does not change. Once again, let me repeat my statement. Because the pressure of a given amount of gas is inversely proportional to volume, therefore, it means that the volume of a gas, whenever it decreases, then the pressure of that same gas will increase. And that is why the relationship is inverse proportionality. Now to graphical representation of Boyle's law. In the first graph of pressure versus volume, that's P versus V, relationship tells us that this is inverse proportionality. And the shape of the graph is curved or rectangular hyperbola because the change is inverse. This means that as volume increases, pressure decreases. In the second graph of pressure versus 1 over volume, from the relationship, we can see it's a direct proportionality relationship. Then the shape. It's a straight line through the origin because it has the same form of the straight line equation, which is y equals to mx. Then in a straight line equation, y is dp, x is 1 over v, and m is the slope, which is k. In the third graph of volume versus 1 over pressure, the relationship shows direct proportionality. Then the shape shows that straight line through origin, just like the former one. In the fourth graph of PV versus P, from Boyle's law, PV equals to K, and then the shape of the graph will be horizontal straight line. That is, PV does not depend on P, meaning product of P and V is constant. In the fifth graph of log P versus log V, also from the equation PV equals to K, taking the log of both sides and rearrange, the equation becomes log P equals to minus log V plus log K. Then the shape shows a straight line with negative slope, which means the slope is equals to minus 1, meaning it confirms the inverse proportionality between P and V. Now, practical applications. The law helps us to understand how gases behave. When breathing, during inhalation, lung volume increases and the air pressure in the lungs decreases. Also, during exhalation, lung volume decreases and the air pressure in the lungs increases. The second point is using a syringe. When the plunger is pushed, volume decreases, pressure increases, then liquid is forced out. Another application is using bicycle pump or air pump. Now the piston compresses the air, volume decreases, pressure increases, then air enters the tire. Another application is using aerosol spray cans. In the spray can, gas is stored under high pressure. When the nozzle is pressed, gas expands rapidly, then the liquid spray is pushed out. Now let's look at an example. From the example, 200 centimeter cube of a gas has a pressure of 510 millimeter mercury. What will be its volume if the pressure is increased to 780 millimeter mercury, assuming there is no change in temperature? Now, from the solution, we can see that V1 is equals to 200 centimeter cube, P1 is equals to 710 millimeter mercury, P2 780 millimeter mercury, and V2 is unknown. So then from the relationship of Boyle's law, P1 V1 equals to P2 V2, then we substitute the values and the final answer will become 130.8 centimeter cube. Moving on to Charles' law. Charles' law states that the volume of a given amount of gas is directly proportional to its absolute temperature, provided the pressure remains constant. Mathematically, Charles' law is expressed as V directly proportional to T. And when removing direct proportionality, it becomes V equals to KT. Then cross multiplying, we have V over T equals to K. And because gas moves from one state to another, the formula becomes V1 over T1 equals to V2 over T2, where V1 and V2 are initial and final volumes, T1 and T2 are initial and final absolute temperatures. Now, from the relationship of V and T in the law, it means that if the temperature of a gas increases, the volume also increases, and vice versa, as long as the pressure remains constant. Graphical representation of Charles law. From the first graph, we could see that the volume versus the temperature in Kelvin have a straight line. And in the second graph, which is the volume versus the temperature, in this case, measured at degrees Celsius, the straight line does not pass through the origin 0. It actually starts or pass through minus 273.15 degrees Celsius. So that's the difference between the two graphs. The first one is measured at, the temperature of the first one is measured at Kelvin. The temperature of the second one is measured at degree Celsius. Now let's look at the example of Charles law. A fixed mass of gas of volume 546 cm3 at 0 degrees Celsius is heated at constant pressure. What is the volume of the gas at 2 degrees Celsius? Now from the solution, T1 equals to 0 degrees C, V1 equals to 546 cm3, V2 is unknown, and T2 equals to 2 degrees Celsius. And the next thing is to convert the temperatures to Kelvin, because the two temperatures given are in degrees Celsius. So we need to convert them to Kelvin. So T1, which is 0 degrees C plus 273.15 equals to 273.15 Kelvin. T2 is equals to 2 degrees C plus 273.15, now giving us 275.15 Kelvin. Then apply the Charles law, which is V1 over T1 equals to V2 over T2, making V2 the subject of formula and substituting, the final answer becomes 550 centimeter cube. It shows that the volume of the gas at 2 degrees C is 550 centimeter cube. Now moving on to the next law, Gay-Lussac's law, or simply pressure law. Gay-Lussac's law states that the pressure of a given amount of gas is directly proportional to its absolute pressure, provided the volume remains constant. Mathematically, Gay-Lussac's law is expressed as below. P is directly proportional to T. Then by removing the proportionality sign, P equals to KT. And by cross multiplying, we are going to have P over T equals to K. And then the final formula will become P1 over T1 equals to P2 over T2. This means that if the temperature of the gas increases, its pressure also increases, and vice versa, assuming the volume does not change. Practical applications. The law is a crucial part of understanding the behavior of gases in fixed containers like pressure cooker and aerosol can. Moving on to the next law, the general gas law. The general gas law combines the relationship described in Boyle's law, Charles law, and Gay-Lussac's law. It provides a comprehensive equation to describe the behavior of a gas when pressure, volume, and temperature all change simultaneously. Now, the law states that the product of pressure and volume divided by temperature is constant for a fixed mass of gas in a system. From the law, mathematically it can be expressed as below. PV over T equals to K. Then P1V1 over T1 is equals to P2V2 over T2. The equation applies to a fixed amount of gas, that is constant number of mole. So from the formula or from the law, we can see that the three laws has been combined together in one. Example: the volume of a given mass of gas is 300 cm3 at 15 degrees C and 700 mm mercury. What will be its volume at 36 degrees C and 760 mm mercury? Now from the solution, like we did earlier, temperature must be converted to Kelvin. So T1, which is 15 degrees C, plus 273.15 equals to 288.15 Kelvin. The same thing for T2 converted to Kelvin. By substituting all our values, the final answer will become 296.45 centimeter cube. The ideal gas law. The ideal gas law states that the product of pressure and volume of a gas is equal to the product of the amount in mole, gas constant, and temperature of the gas in a system. the law assumes the gas behaves ideally, meaning its particles have no volume and no interaction with each other. So remember that ideal gas do not have volume and there is no interaction between them. So the law explains this fact. And using the expression PV equals to nRT, where nR equals to K. Then the example says, calculate the number of moles present in a certain mass of gas occupying 6.5 dm cube at 3 atm and 15 degrees C. Given that R is equals to 0.0821. Solution. Then from the formula, PV is equals to nRT. Making N, which is the number of moles, the subject of the formula, we have PV over RT. Then the temperature given, which is 15 degrees C, will be converted to Kelvin. That's 15 degrees C plus 273.15 equals to 288.15 Kelvin. Then substituting the values and then calculate, we have N equals to 3 multiplied by 6.5 all over 0.0821 multiplied by 288.15. Then our answer, or the number of moles, will become 0.82428 mole. You can attempt the practice questions on your own. Feel free to comment, ask your questions in the comment section. Thank you for watching.